Have you ever wondered what actually happens when you ask ChatGPT a question? How does an AI model instantly generate paragraphs of coherent text, write code, summarize documents, or even reason through complex problems? Despite all the hype around large language models, most people don't know what's happening behind the scenes. In this video, we'll break down the entire token generation process, from your prompt entering the model to every single word being generated. By the end, you'll understand how modern LLMs like GPT, Claude, Gemini, and Llama actually think, or more accurately, predict. First, let's clear up the biggest misconception. LLMs don't understand language the way humans do. They don't possess beliefs, intentions, or knowledge in the traditional sense. At their core, LLMs perform one surprisingly simple task: predict the next token. The model calculates probabilities and chooses the most likely continuation. Everything, from essays to code generation, emerges from repeating this process billions of times. Before a model can process language, it must convert text into tokens. A token isn't necessarily a word, it's a chunk of text. The word hello may become a single token, but unbelievable may become 3 pieces: unbelieve and able. Different models use different tokenizers. For English text, 1 token is often around 3 to 4 characters. The sentence you're hearing right now is being broken into hundreds of tokens before entering the model. Inside the model, everything becomes numbers. Now the magic begins. Each token is transformed into a high-dimensional vector called an embedding. These vectors capture relationships between concepts. Words with similar meanings end up closer together in vector space. The word cat and the word dog are closer to each other than they are to the word airplane. This allows the model to learn semantic relationships without explicit programming. In 2017, researchers introduced the transformer architecture. This changed everything. The key innovation was attention. Attention allows every token to look at every other token in the sequence. Consider the sentence: the trophy doesn't fit into the suitcase because it is too large. When the model sees the word it, attention helps determine that it refers to the trophy, not the suitcase. This mechanism enables modern LLMs to maintain context across thousands, or even millions, of tokens. Now let's watch generation happen. The model receives your prompt: explain gravity in simple terms. Step 1. The model processes the entire input. Step 2. It outputs probability scores for every possible next token. Gravity might score 42%. It might score 15%. It might score 11%. Step 3. The model selects the most likely token. Step 4. It appends that token to the context and repeats: gravity, then force, then that. Every response is generated 1 token at a time, in a tight loop. Why doesn't the model always generate the exact same response? Because of sampling. A temperature setting controls how the model samples from its probability distribution. Lower temperatures make responses more deterministic and focused. Higher temperatures increase. Asking for a story might produce something wildly unexpected. At low temperatures, the same prompt produces the safe, expected answer. Hallucinations happen when the most probable next token isn't actually correct. The model isn't querying a database by default. It's generating what statistically looks right, based on patterns in its training data. It can confidently fabricate a citation, a date, or plausible, even if it's factually wrong. Probability is not the same as truth. This is why verification remains critical when working with LLM outputs. Modern systems are evolving far beyond simple next token prediction. Models now use reasoning chains, tool calling, memory systems, retrieval augmentation, and autonomous agents. A user query can trigger a retriever that fetches relevant documents, a reasoning model, tool calls that run code or search the web, and finally a synthesized response. But underneath all these innovations, token generation remains the foundation. So the next time ChatGPT, Claude, Gemini, or another LLM answers a question, remember what's happening under the hood. It's not magic. It's a massive probability engine predicting 1 token at a time, billions of times over. And somehow, that simple idea has transformed the world. If you found this helpful, hit like, subscribe, and let me know in the comments which AI topic you'd like demystified next. See you in the next one.